Okay, welcome back. This is Mr. Hassan's Maths channel, and this is paper 1, variant 2 from the Pure Mathematics syllabus of Cambridge 9709, the A-level paper from October-November 2023. So this question here, we have the equation of a curve is y equals f of x, where f of x is equal to 4x minus 3 to the power of 5 over 3 minus 20 over 3x. Find the x-coordinates of the stationary points of the curve and determine their nature. Okay, so first of all, we need to understand what we mean by stationary points. And we have to understand that we only want the x-coordinates. And also that there's another part of the question where it says, and determine their nature. So many people, they skim read or they don't actually read the whole question. All right, so you have to be very careful when you're answering such questions that you answer the whole question. Right, so first of all, work out what you are supposed to do. So you're going to find the x-coordinates only of the stationary points and then determine their nature. So now, stationary point. What does it mean by stationary point? Now, a stationary point is a point of zero gradient. A point of zero gradient. So you can either have a maximum when the curve turns like this, or you can have a minimum where the curve turns like this, or you can have a point of inflection, which could be this way or the other way around, where the graph becomes a zero gradient for an instant and then it goes back up the same way it was going. Okay, so most stationary points we will face would be either maximums or minimums. Okay, so that would be like if I drew a tangent at that point where it turns, that tangent would have a gradient of 0. Okay, so that would have a gradient of 0. If I drew a tangent at this point, it would have a gradient of 0 as well. Okay, that's for the minimum, and also for the point of inflection. If I was to draw a tangent at the point where it kind of changes curvature, okay, then at that point where it changes its curvature, somewhere over there would be 0, the gradient. Okay, that's supposed to be straight, sorry. Okay, so these are the stationary points. Okay, so you can either have a maximum or a minimum or a point of inflection, and that's what they mean by determine their nature. So the first step is to find the coordinates or the x-coordinates of the stationary points. So the stationary point is when the gradient function is equal to 0. So the gradient function is found, and the gradient function is denoted by, if your equation is in terms of y equals, then you say dy dx equals. If it's in terms of f of x equals, then it's f dash of x equals. So here we have our original function f of x equals. Now we can make sure that everything's correct in terms of everything's in the right format to be differentiated, and it is. Everything's in index form and all the variables are on the numerator. So you have 4x minus 3 to the power of 5 over 3 minus 20 over 3x. So the first step is to differentiate this function with respect to x, which you know as f dash of x. So we multiply by the power. So we're going to multiply. Here we have to use the chain rule for this term here, because you have a function inside another function. You have something raised to a power, and inside it is a function in itself. So we have to use the chain rule, and a lot of people mess up with this, so you have to be careful. So you multiply by the power. So I'm going to do 5 over 3 multiplied by the bracket 4x minus 3, but then I take 1 from the power. So 5 over 3 minus 1, which is 5 over 3 minus 3 over 3, which is 2/3. Then don't forget to multiply by whatever is inside here differentiated. So 4x minus 3, if you differentiate, you get 4. So you multiply by 4. And then x term loses the x. So it's 20 over 3, just on its own without any x, because basically 20 over 3x, if you differentiate this, and it starts off with 20 over 3x to the power of 1. That power of 1 is not written. When you multiply by the power, this stays as 20 over 3. And x becomes, you take 1 from the power, becomes x to the power of 0. Well, we know x to the power of 0 is equal to 1, so you end up with 20 over 3. That's why any x term, the x is dropped when you differentiate it. Okay, so now we have our gradient function. Let me just write it out simplified a bit. So we have 5 times 4, which is 20, over 3 times 4x minus 3 to the power of 2/3 minus 20 over 3. So here we have the gradient function. Now we have to find when the gradient function is equal to 0. So I'm going to take this gradient function, 20 over 3 times 4x minus 3 to the power of 2/3 minus 20 over 3, and I'm going to equate it to 0 to find the values of x where the gradient is equal to 0. That will tell me, okay, where the stationary points are. So first thing I can do is I can multiply both sides of the equation by 3 and divide by 20 over 3 to get rid of this. Okay, so you can say multiply by 3 both sides and divide by 20. Okay, or so I can do the same here. Okay, so basically this will cancel out, so you're left with 4x minus 3 to the power of 2/3 minus 1 is equal to 0. 0 times anything is. So that just simplifies, gets rid of that fraction. Now we can subtract 1 from both sides, so 4x minus 3 to the power of 2/3 is equal to 1. Now remember what this means is the cube root of 4x minus 3 squared. Okay, and if you want to then find the cube root of both sides, this becomes 4x minus 3 squared. The cube root of 1 is just 1. It's an odd power, so it just has the sign that it has. And then you want to find the square root of both sides. So you want to get rid of the cube root, you have to cube both sides. So you cube both sides, so this becomes 1. And this becomes 4x minus 3 squared. So you cube this side, the cube root disappears. You cube this side, it becomes 1. 1 cubed is 1. I don't know what I said before, just ignore that. And here we have 4x minus 3 squared equals 1. So here we can take the square root of both sides. Now, there's two values of 4x minus 3 that would give you 1. If 4x3 equals 1, 1 squared would give you 1. If 4x3 equals minus 1, then that would also be minus 1 squared gives you 1. So 4x minus 3 could possibly be plus or minus 1. Okay, that's why we have two stationary points here. As we can see, it says find the coordinates of the stationary points. Not point, but point. So there's more than one. In fact, there's two. So now we can say that 4x is equal to, if you add 3 to both sides, 3 plus or minus 1. So x is equal to 3 plus or minus 1 over 4, which means x is equal to 3 plus 1 over 4, which is 4 over 4, which is 1. Or x is equal to 3 minus 1, which is 2 over 4, which is a half. So those are the x coordinates of the stationary points, and the first part of the question is answered. Okay, so an alternative way of completing this after this step over here would be to basically do the following. If you don't like this particular method here, you could do this. You have 4x minus 3 to the power of 2/3 is equal to 1 from this stage over here. Okay, now what we can do is, instead of taking cubing both sides and then finding the square root of what's in there, or whatever, what we can do is the following. We can raise this to the power of the reciprocal of the power it's already raised to. So 2 over 3 is reciprocal of 3 over 2. So I'll do the same to the other side, raise that 1 to the power of 3 over 2. The reason why this works is because when you raise something that's raised to a power to another power, you have to multiply the powers. Okay, so if I multiply 2/3 by its reciprocal, it gives me 1, which cancels it out basically. So it leaves you with 4x minus 3 on its own to the power of 1. And 1 raised to the power of anything is going to be 1 anyway. You know, the square root of 1 is 1, 1 cubed is 1. But remember, when you find the square root, you have to put plus or minus. Okay, because this is like, be very careful there. This is where you have to be careful. Because this is like, as we discussed now, it's like the square root of 1 cubed. So the square root of the 1 cubed is 1. The square root of 1 is going to be plus or minus 1. Okay, plus or minus 1. This means, because we've put the square root there ourselves. We're the one that put the square root sign there ourselves. So you have 4x minus 3 equals plus or minus 1. So then you can get the same answer. You're going to have x equals basically 3 plus or minus 1 over 4, which gives you the same answer. So that's an alternative way of doing it, if you don't like this method here. But you end up with your two stationary points. Now, we haven't finished there because it says, and determine their nature. So if we have enough space here, I think we do, determine their nature. Now, to determine the nature of the stationary points, okay, what we need to do is we need to think about what's called the second differential. Okay, the second differential, which will be when we take this expression here, which I'm going to write down here now, f dash of x, it's 20 over 3. So you have f dash of x, this is the second differential, is equal to 20 over 3 times 4x minus 3 to the power of 3 over 2 minus 20 over 3. That was the first differential. Okay, that's the gradient function. Okay, good. Now, if we have a look at these diagrams here, this is a maximum. And a maximum, the gradient is changing. So what we have to find is we have to find what's called the second differential, which is f dash dash x. If you got y, you get dy dx, and then you get the second differential is d squared y dx squared. If you start off with f of x, then dy dx is f dash of x, and d squared y dx squared is f double dash x. It means the same thing. First differential, second differential. So we got to find the second differential. Now, what does the second differential tell us? It tells us the rate of change of the first differential, the rate of change of the gradient. So here the gradient starting off positive and it's becoming negative. So the gradient, its value is decreasing the whole time. The gradient value is going from positive to negative, it's decreasing. So when you have this question, when you have this situation where the second differential is going to be decreasing, that means the second differential at this point is going to be less than 0, which means we have a maximum. So when you find the value of x, okay, for a point, and you substitute it into the second differential, and it comes out as a negative value for that point, that means there's a minimum at that place. Okay, and if you consider a minimum, it's going from negative to positive. So the gradient is increasing as you go along. As you go along, the gradient is increasing. So therefore, we can say f double dash of x is going to be greater than 0 when we have a maximum point. Okay, as for points of inflection, we can deal with them if we get to that. Let's see what happens in this case. Okay, so first of all, we got to find the second differential, which is multiply by the power. So 20 times 3, which is 60 over, was it 3 over 2 or 2 over 3? My bad. I almost messed up there. That's actually 2 over 3. I wrote it down wrong. It's supposed to be 2/3. So that's going to be 40 over 9 times 4x minus 3. Don't forget, multiply by the differential of what's inside the function, which is the 4. And the constant term becomes 0 when you differentiate it. So we're left with the second differential is given by 160 over 9 times 4x minus 3 to the power of minus 1/3. Okay, to the power of minus 1/3. Why? Multiply by the power, take 1 from the power. So that's going to be to the power of 1/3. Okay, so we can say that the second differential, therefore, is equal to 160 over, let's write it like this, 9 times the cube root of 4x minus 3. Okay, let me make it a bit neater there. Okay, so it's going to be, the second differential is 160 over 9 times the cube root of 4x minus 3. That's the second differential, and we have the two values, x equals a half and x equals 1, where we have the stationary points. So I'm going to take this information to the next page. So we have the second differential was equal to 160 over 9, 160 over 9 times the cube root of 4x minus 3. Okay, let me just be sure of that. Yep, and have x equals a half and x equals 1. So when x equals a half, you have the second differential is going to be 160 over 9 times the cube root of 4 times a half is 2 minus 1 is minus 3. So the cube root of minus 1 is minus 1. So you end up with negative 160 over 9. So when x equals a half, the second differential is less than 0. Therefore, when x equals a half, we have a maximum. Okay, so x equals a half is a maximum. And when x equals 1, we have the second differential is going to be 160 over 9 times 4 times 1, which is 4 minus 3, which is 1. So the cube root of 1. So it's 160 over positive 9, all right, which is greater than 0. So when x equals 1, the second differential is greater than 0. Therefore, we have a minimum. Okay, so when x equals 1, we have a minimum. So we found the coordinate, or the x coordinate, and the nature of the stationary points for this curve. Okay, and that's the answer to part A. All right, so that's a very important question. Then for part B, it says state the set of values for which the function f is increasing. So we see that there are two stationary points when x equals a half and x equals 1. Now we don't know what the graph looks like, and we don't really need to know what the main graph looks like. We just need to have an understanding of what's happening. So just imagine, this is the x-axis, all right? We know that x equals a half would be here and x equals 1 would be here. I don't know what the y coordinates are, and I don't really need to know. I'm not going to make an accurate sketch, but I know that x equals a half, we have a maximum. So the graph will have this kind of shape at x equals a half. And x equals 1 is going to be a minimum. So it's going to have this type of shape at x equals 1. So this will be when x equals a half, and this is when x equals 1. So we want to find the set of values for which the function is increasing. Now a function is increasing when the gradient function is greater than 0. Okay? When the gradient function is greater than 0. So what we could do here, we could make things complicated and find the gradient function and try to solve the inequality f dash of x is greater than 0. But here we don't need to do that because we've found enough information in the previous part of the question to give us the idea that the gradient is increasing when it's positive, when the gradient is positive. And we can see the gradient of this curve. We haven't done an accurate sketch, but we know that there's a maximum here at x equals a half, and there's a minimum at x equals 1. Between a half and 1, we see there's a negative gradient. That means the function is decreasing in this range. It's decreasing between half and 1, which is the opposite of what we want. And we can see it's going upwards when x is less than a half. When x is less than a half, it's increasing. The gradient's getting bigger. And when x is greater than 1, also the gradient's getting bigger. Okay, so it's increasing when x is less than a half or when x is greater than 1. So if you want to write it in set notation, you could say, x is such that x is less than a half or x is greater than 1. But there's no need to. If you write it like that, that's fine. Okay, those are the values of x for which it's an increasing function. Okay, so there's only one mark here. There's no need for us to actually, equate the first differential to 0 and solve the inequality. That will just make things overcomplicated. We have done enough work up to now, all right, in finding the stationary points and the nature of the stationary points for us to be able to answer this question in a few seconds. Okay, so there's the answer to part B of this question, and I think that was this question. Done. Other questions from this particular paper can be found in the playlist that will appear in this section over here. Other questions from the topic of differentiation, I guess is all to do with differentiation, can be found in the playlist that will appear in this area over here. You can subscribe to my channel by clicking on this link. In fact, over here I'll put some work from differentiation from P1 and here differentiation from P2 of my edXL collection. Thank you for watching and see you soon.